Hello everyone, welcome to Neso Academy. In the previous lectures, we have already understood three different types of constructors. We have studied default constructor, parameterized constructor, and copy constructor. Now in this lecture, we will understand the fourth type of constructor, which is the move constructor. So without any further delay, let's get started with this lecture and let's see what are the topics. The first topic is rvalue reference. Before understanding move constructor, we will first understand rvalue reference, which is important to implement the move constructor. Then we will move to the next topic where we will understand the move constructor. So these are the topics of this lecture. Let's start with the first one, rvalue reference. Now what is rvalue reference? Before understanding rvalue reference, we need to have proper understanding about lvalue and rvalue. Let's first understand what is the meaning of lvalue. Lvalue is an object that occupies a persistent memory location. What is the meaning of persistent memory location? By persistent memory location, I mean the memory location to which we can directly refer to. We can access the address of that memory location and store it in some pointer in our source code. Through that pointer, we can manipulate that memory location if we want. So, a persistent memory location is the memory location which we can directly access in our source code. Compiler will not throw any error and it will allow us to access the memory location. Now, the persistent memory location gets deallocated when lvalue associated to that memory location goes out of scope. So, this is what persistent memory location is, and this is the meaning of lvalue. Lvalue is an object that occupies a persistent memory location. Now, what is rvalue? Rvalue is a temporary value which does not have a persistent memory location. So, it has a non-persistent memory location or a memory location which we cannot directly access in our programs. We cannot access that memory location and we cannot modify that memory location. We cannot store the address of that memory location in some pointer. It is a temporary memory location where the temporary value called rvalue will be stored. Now, when the expression of which the rvalue is part of gets evaluated completely, then this non-persistent memory location gets deallocated. So I hope it is clear to you what is rvalue. Rvalue is a temporary value which does not have a persistent memory location. Now to understand these points properly, that is, to understand the meaning of lvalue and rvalue properly, let's take one simple example. Here in this example, I have defined variable x of type integer and I have initialized it with value 10. Variable x has a persistent memory location because we can access that memory location in our program and we can modify it as well. We can get the address of that memory location with the help of ampersand operator, and we can store that address in some pointer if we want to. Also, the memory location associated to x gets deallocated when this variable goes out of scope. If this variable is defined in a main function, then after completion of the main function, the memory associated to this variable will be deallocated. So clearly, x has a persistent memory location and therefore x is an lvalue. Now what can we say about value 10? This is an rvalue because it does not have a persistent memory location. We cannot access that memory location directly in our programs. We cannot apply the ampersand operator in front of this value to access the address associated to this value. This is not possible in C++. Therefore, we can say this is an rvalue. It does not have a persistent memory location. Also, when this line completes its execution, memory associated to this value will be deallocated, because the purpose of this value is to be stored in this variable x. Once this job is done, memory associated to 10 will be deallocated. I hope this is clear to you. Let's take one more example. Here we have this expression and we can observe that x is an lvalue and 20 is an rvalue. Here if we want, we can store the address of x in the pointer p. This is allowed in C++. We can use ampersand for this purpose. But we cannot do something like this. We cannot store the address of value 5 in the pointer p. This is an rvalue. We cannot access the address of the memory of this specific value. So with this, we have learned the difference between lvalue and rvalue. Now let's understand what is lvalue reference and rvalue reference. Lvalue reference binds to lvalue and rvalue reference binds to rvalue. As simple as that. We know what a reference is. A reference is an alias, or we can say just another name of some object. We have two types of references in C++. We have lvalue reference and rvalue reference. As the name suggests, lvalue reference binds to lvalue. This means it is the reference to an lvalue, and rvalue reference is the reference to rvalue. Lvalue reference cannot be the reference of rvalue. Similarly, rvalue reference cannot be the reference to lvalue. Now to make this more clear, let's consider one example. Here I have written this line. I have defined this reference LR. This is an lvalue reference. This is how we define an lvalue reference. We need just one ampersand symbol. Here we have LR, which is the reference to variable x. Therefore, we can use this name in place of x. Here we can also observe that x is an lvalue, and therefore this line is perfectly valid. This is the lvalue reference. Now what if we write this line? Here we also have the lvalue reference, but this lvalue reference is referring to an rvalue. This is not possible. We cannot do this in C++. Lvalue reference can only bind to lvalue. But here we are trying to bind it to rvalue. So this is not allowed. Now what if we want to create reference for this value 5? That is how we can create a reference to an rvalue. For this purpose, we need to define an rvalue reference. And this can be done by using two ampersand symbols. This is how we can define an rvalue reference. Here we need two ampersand symbols in order to define rvalue reference. Now this is the reference to value 5. This is perfectly valid. So with this, we have properly understood the difference between lvalue reference and rvalue reference. Now we know what is rvalue reference. And you might be thinking, why do we need rvalue reference? What is the significance of rvalue reference? Rvalue reference allows us to capture temporary object in the move constructor and move its resources to another object. The job of move constructor is to move the resources of one object to the other object. That is, when we want to transfer the ownership of one object to the other object, then we use the move constructor. In order to use the move constructor, we need rvalue reference. We need rvalue reference to the temporary object of which we want to transfer the ownership. So this is the significance of rvalue reference, and that is why we have studied rvalue reference. So we have understood rvalue reference. Now we are ready to understand move constructor properly and how we can use move constructor in C++ programs. With this, we are done with the first topic, rvalue reference. Now let's move to the second topic to understand move constructor. Move constructor is the constructor that allows stealing resources from a temporary object and provide those resources to some other object. This is what move constructor is. Move constructor allows us to transfer the ownership of one object to the other object. Now this can be well understood through an example program. Let's take the example program. Here I have included IOStream and C string header files. I have included C string header file because I am going to use strlen and strcpy functions in my program. Here I have defined this class myString, and this is the definition of the private data member data. This pointer can point to a character, but we know it can point to a string as well. This is what we have learned in our previous lectures. Now here inside the main function, I have defined the object s1 of class myString, and I want to initialize it with the string hello. I in reality want to provide this string to this pointer. I want that the data pointer should point to an array which is allocated in heap, and that array should have the capability to hold this string hello. This means I want that s1.data should point to the string hello. Now for this purpose, we can define a constructor. We know in order to initialize this object, we need a constructor. So here is the constructor that I have defined for this purpose. This is my string constructor. S is the pointer, which is the pointer to constant character. It can point to this string, so it will receive this string. Now through new operator, I want to allocate an array in the heap, and that array should have the capability to hold this string. That is why I have provided the data type as char, and within brackets I have provided the size. strlen s will give the size of the string, which is 5. And 5 plus 1 is 6. I have added 1 because I want one memory location to be reserved for null character in the array. So that is why I have added this 1. We will get the size of this array as 6. So we will get a total of 6 blocks in the array where each block can hold a character. This new operator will return the address of the first block. We can store that in s1.data. Now s1.data can point to an array that can hold 6 characters. I hope this is clear to you. Now after this, through strcpy, I am copying this string to the array. And then with the help of stdcout, I am trying to display constructed on the screen to show that the s1 object has been constructed. So we know after execution of this code, we will get a new array with 6 blocks where each block can hold a character. Eventually that array will hold this string along with the null character, and constructed will be displayed on the screen. Now let's say I want to create a new object as the copy of this object s1. For this purpose, I have written this line. s2 is the new object that is created as the copy of the s1. Here we need to define the copy constructor for this purpose. This is how the copy constructor looks like. Here I am performing the deep copy. We have already learned the deep copy. Here I have provided this reference as the parameter. This is the reference to s1. We know s1 is an lvalue. Here you can observe that S1 is an L value. It has a persistent memory. It is the object that has the persistent memory location. So clearly, I need to define an L value reference. That is why I have defined this L value reference other. And I have provided this const keyword here to tell that I am not going to modify this object. Within these braces, I have written this line. This line allows us to create a new array with this specific size. Here to the strlen, I have passed other.data. We know other is the reference to S1. So we know this is S1.data. Now we know this that S1.data is pointing to an array which has this string hello along with the null character. So from here we will get the length of the string as 5. Null character is not included in the count. I have added one here so that we will get memory location for the null character as well in the new array. This new operator will return the address which will be stored in s2.data because S2 has invoked this constructor. I hope this is clear to you. Now S2.data is pointing to a new array with 6 blocks, where each block can hold a character. Through strcpy, I am copying s1.data to s2.data. This means I am copying this string to the new array. So now we have two arrays. S1.data is pointing to an array with the string hello, and S2.data is pointing to another array, a new array with the string hello. Now I hope this is clear to you. In this way, I have performed the deep copy. We already know how to perform deep copy. Now S2 is the copy of S1, and copied will be displayed on the screen. This is the copy constructor. Now after this, let's define the destructor for both these objects, because when the function completes execution, then these objects must be completely destroyed. And for this purpose, we need destructor like this. When this destructor invokes on S1, then array associated to S1.data will be deallocated and destroyed will be displayed on the screen. When this destructor is invoked on S2, then array associated to S2.data will be deleted, or we can say deallocated, and destroyed will be displayed on the screen. So we know this, that destroyed will be displayed twice on the screen. Now let's define the print function to print the strings stored in the arrays on the screen. When print function is called through S1, then the string associated to S1.data will be displayed. When this function is called through S2, then string associated to S2.data will be displayed on the screen. Now here, we need these two lines in order to print the strings. We know when we execute this program, we will get this output. First, we are getting constructed because of this line. Then we are getting copied because of this line. This means copy has been created successfully. After this, we are getting hello twice because of these two print calls. We are calling this function for S1 and S2. That is why we are receiving this output. And then destroyed is printed twice. I hope this program is completely clear to you. So here I have successfully created the copy of S1 as S2. Now let's say the requirement is to move the resources of S1 to S2. That is, we want to transfer the ownership of S1 to S2. For this purpose, we should not use the copy constructor, because copy constructor will create the copy of S1 and provide it to S2. This means we will get two different arrays. We do not want two different arrays. We only want one array which is pointed by S2.data. That is, we want to transfer the ownership. So for this purpose, we need a special type of constructor called the move constructor. Because move constructor allows us to transfer the ownership of one object to the other object. Now, in order to define the move constructor, we need to tell the compiler that S1 should be treated as a temporary object. Now, this can be done with the help of std move, like this. To std move, I have provided S1 as the object. With this, we are telling the compiler that S1 should be treated as a temporary object, and therefore, the ownership of S1 should be transferred to S2. I hope this is clear to you. Now, we need to define the move constructor in place of this copy constructor. We know that S1 is now treated as a temporary object. Therefore, we need an rvalue reference here. We need rvalue reference because rvalue reference can bind to rvalue, and rvalue is a temporary object. So, this temporary object is an rvalue. That is why we need rvalue reference here. Now, to define the rvalue reference, we need one more ampersand symbol. Also, we do not need this const keyword here because we will modify the S1 object in this constructor. So, we need to remove this const keyword here. Now, let's replace these three lines by these lines. Let's understand these lines one by one. Here we have data equals other.data. This is same as S2.data equals S1.data. Other is the reference to S1, and S2 has invoked this constructor. That is why we have S2.data equals S1.data. This means S2.data is also pointing to the same array which is pointed by S1.data. This is what it means. So now both the pointers are pointing to the same array with the string hello. I hope this is clear to you. Now after this, I am transferring the ownership. Here I have written other.data equals null ptr. Now what is the meaning of null ptr? Null ptr is the keyword that is used to define a null pointer. And null pointer is something that does not point to a valid memory location. We only want that S2.data should point to the array, not S1.data. We know at this point, S1.data and S2.data are pointing to the same array with the string hello. But I want that S2.data should only point to the array. For this purpose, I am setting S1.data as null pointer. So in this way, S1.data will not point to the array which it was previously pointing to. So in this way, I have transferred the ownership of S1 to S2. In other words, S2.data is now pointing to the array. I hope this idea is completely clear to you. Now after this, through stdcout, I am displaying moved on the screen. So this is the move constructor. Now we also need to modify this print function so that when data is a null pointer, then the string empty must be displayed on the screen. If data points to a valid string, then that string must be displayed. So here I have modified this print function in this way. If data is not a null pointer, then the string pointed by data must be displayed. Otherwise, empty must be displayed. I have written this code in a single line because of the lack of space. Now we know what happens when we execute this program. We will get this output. First, we are getting constructed because of this line. then we are getting moved. This means resources of S1 have been moved to S2, and now S1.data is a null pointer. After this, empty is displayed and hello is displayed. We are getting empty because of S1.print. We know S1.data is a null pointer. That is why we are seeing empty as the result. And because S2.data is pointing to the string hello, so hello is displayed. Now after this, destroyed is displayed twice. This is because this destructor is called twice for these two objects. So that is why we are seeing this output. In this way, the move constructor works. I hope this is completely clear to you. So when we want to transfer the ownership of one object to the other object, then we use the move constructor for this purpose. So with this, we have understood move constructor properly. This means we are done with the second topic also, and this means we are done with this lecture. Okay friends, this is it for now. Thank you for watching this lecture. I will see you in the next one.